Number C10, Robert is sliding down a rough slide that is 3.8 meters long and forms a 43.2 degree angle with the ground. If his mass is 47.3 kilograms and the speed at the bottom of the slide is 6.38 meters per second, what percentage of his potential energy was converted to heat? Well, in this problem, we really have a couple very simple problems that we do at the same time. At the top of the slide, of course, the type of energy that he has is potential energy. So potential energy is just mgh. Well, we know his mass up there is 47.3. We know g, of course, is 9.81. And we know his height is, we don't know his height. We know that the slide is 3.8 meters long, but that's the length of the slide at an angle. The height is going to be straight up and down. So here we're looking at the opposite side, so we want to use the sine of 43.2 times the length of the slide, which was 3.8. If we do that in our calculator, we find that there are 1,207 joules of potential energy at the top of the slide. Well, when he gets to the bottom of the slide, he no longer has potential energy. Down here, he has all kinetic energy. So kinetic energy is mv squared over 2. His mass is still 47.3 kilograms. But down here, he has a velocity of 6.38 squared over 2, which means he has a total amount of energy down at the bottom of 963 joules at the bottom. Now, of course, if he would have just dove off the slide, then by the time he hit the ground, all of the potential he had at the top would have ended up down here at the bottom. But here he didn't dive off, he slid down. And as he's sliding down the slide, his tuchus is rubbing against the slide. Friction is stealing some of that energy and turning it into heat, which is what friction likes to do. So if we take the total amount of energy we had at the top and we subtract the total amount of energy we have at the bottom, we find that we are missing 244 joules. Now, of course, it's not really missing. It didn't just disappear. It changed into heat. So if we're looking for how much his tuchus heated up, that would be it. He lost 244 joules to heat. So that would be the answer if I just asked you how much heat did he lose, but I asked you what percentage turned into heat. So if we're looking at percentage, then of course we want to say how much did we lose compared to how much did I start off with times 100. And if we do that, of course, we find that he lost 20% of his heat, which is about typical if you're sliding down something like that.